Welcome to the herd and thanks for listening. If you enjoy this sodcast, please like it, share it, give it a good rating, and follow, and help more people find their way into the Ruminati herd. If you have suggestions for improvements, please let me know. Howdy, everybody. Welcome to this episode of the Meet Your Herdmates sodcast. I'm very pleased today to be joined by Dr. Lynn Sollenberger, all the way from Gainesville, Florida. Thank you.
Thanks a lot, Peter. I'm very happy to join you today. I look forward to interacting with you.
Excellent. We're very cool here today. We're only in the mid 70s, so what is it like there?
Well, actually, I think we're probably about the same. It's a beautiful April day. The sky is blue, sun is shining, and I think we're probably mid 70s as well. So it's a beautiful day in Florida.
So how do the pastures look?
Well, they're very happy right now because we've had probably about 4 inches of rain in the last week. And this is typically the time of year between now and, say, the 1st of June that we very often have a spring drought. And so by now, in a normal year, we might be looking at some less happy, less green pastures because they're running short of water. But typically, as we get toward the end of winter, the cold fronts get weaker. And so there's less moisture that comes through the area. And then it's around the 1st of June when our summer rains start. And so during that period, it's a transition period when we sometimes run short of feed and things can get pretty brown and crispy.
And it's also transition time between cool season and warm season?
That's correct. In the northern part of the state, we grow a lot of cool season annual forages that are typical temperate climate forages, clovers, annual ryegrass, small grains. And they are transitioning out at this point, and our summer perennials like Bahia grass and Bermuda grass are coming on.
Well, I've jumped already into the forage geekdom. So before we get too far down, let's put ourselves into the Wayback Machine and imagine that we had just met at something called a party. And how would you introduce yourself if you had that opportunity to say a few things about yourself in brief introduction?
Yeah, this is an interesting one. I have what I call an incremental introduction. And what I mean by that is I throw something out and then I gauge the interest of the person that I'm talking to. Because I think we often overestimate how interested people are in finding out about us, right? Because we think our background is really, really exciting. But at any rate, so I tell people, I lead off by telling them I'm a plant biologist. And if they say, oh, that's nice, what do you think about the weather? Then, I know we're done. But, in many cases, then they'll follow up by saying, well, what do you do with that? And I tell them that I'm a professor at the University of Florida. And if they're still interested, they'll say, well, what does that look like in terms of a job? And so I explained to them that I teach and research. And they said, oh, well, you said plants. Well, what kind of plants do you work with? Well, I work with grasses. Well, I have this problem with my yard. And I say, well, I might be able to help you with that problem, but the grasses that I work with are grasses that livestock consume. And they say, oh, that's interesting. And so then if we continue on, they might say, well, what specifically do you do? And I tell them that I work with plant breeders to develop plants that are more efficient, that do the job that we want done more effectively, that we try to develop management practices that result in more efficient systems, but that are also more environmentally friendly. They're sustainable in that they can be profitable, but yet have limited negative impacts on the environment. So that's my kind of incremental introduction.
Good. I'll have to remember that. But what's the difference between a yard and a lawn?
I have no idea. You would
Oh,
have to ask a turf grass person.
I,
Is there a difference? I
well, the way I manage my lawn is as a yard, not as a
Yard,
lawn.
right. Well,
I just mow it.
one of my undergraduate students said to me one day in class, Dr. Sollenberger, I bet you have the most beautiful lawn in Gainesville. And I said, no, I know how to have the most beautiful lawn in Gainesville, but I choose not to because I don't want to work that hard on my lawn. So I guess I do know the difference between a yard and a lawn, and mine too is a yard. It's an environment that is ecologically very interesting because there are many species and they are in great degree of competition with one another for survival.
Did I hear it right that you have some rhizominous peanut growing in your lawn?
Absolutely. I do. In fact, I planted some more of it just last night. I had some leftover rhizomes from a planting activity that we were doing, and so I just put some plugs in my yard. But yeah, so it produces a beautiful yellow flower, and it flowers consistently, basically through its entire growing season. So it's starting to flower now, and it'll still be flowering until the time of first freeze. So one interesting little tidbit: we are now living in the second house that we've lived in the same subdivision, and you can figure out which ones those two are. Because they're both the ones that have these pretty yellow flowers in the yard.
Excellent. I've been fascinated hearing presentations on perennial peanut as a forage crop.
Right.
But once upon a time, I think I remember reading about peanut hay. Now that would have been the crop peanut,
Mhm.
that the aerial portion would be harvested and utilized.
Right. So that can be done. One of the challenges is that the annual peanut, the ground nut, the peanut that we eat, it is typically very pest susceptible. And so there are a significant number of fungicides and other pesticides that are used in the production of peanut that are not labeled for application to forages. And so unless you have specifically managed that with utilization of that top growth as a forage livestock, as a livestock feed, you can't necessarily just automatically harvest that and feed it.
Okay, so how did you get interested in forages?
Yeah, well, so serendipity is a key word here. So I grew up on a dairy farm in South Central Pennsylvania, located between Chambersburg and the town that most people know, Gettysburg. So I'm about 19 miles west of Gettysburg, and the story has it that the Confederate soldiers actually marched past probably what is now, my family farm. I was the fourth generation of Sollenbergers on that farm. And so I have these very deep roots and this long history of connection with agriculture. My great grandfather built the barn and the farmhouse that still sit on that property in the early 1880s. So that was the beginning of my interest in agriculture. I did an undergraduate degree in biology, and at completion of that was actually interested in doing some international agricultural development work, but I felt like I didn't have the technical background. I had the practical background, but not the technical background. So I went to graduate school, and I looked at a couple of graduate schools, but when I interviewed at Penn State, it turned out that the uh, funding option was with a guy who was mentioned by Gary Lacefield in your podcast with him, Bill Templeton. And Bill had done basically a career at the University of Kentucky, but then took an administrative post with USDA ARS at State College on the Penn State campus. Bill's a forage guy. He was looking for someone to work with him on grass legume mixtures. I didn't really have a strong persuasion as to what area of agronomy I worked in. And so that sounded good to me. And I got captured, I got hooked. And so, from there, then it was on to a PhD, and I stayed within the forage area and have worked in that area throughout my entire career.
So Bill Templeton would be one of your key influencers, mentors, but are there others that you've come across in the course of your career that you'd look back and count yourself, sort of a descendant of theirs?
Yeah, it's interesting that my mentor at the University of Florida, or one of them, I'll mention a couple of them, was Jerry Mott. And it turns out that Jerry was actually Bill Templeton's major professor.
Okay.
So Jerry basically did a career at Purdue University, and it was at Purdue where Bill was his graduate student. So I worked with the pupil, the mentee, so to speak, at Penn State. And by that time, then Jerry Mott was at Florida. And so I worked with the mentor at Florida. And Jerry was very instrumental in my career development. And also, while I was here, I had a couple of other mentors. I'm linking back to Kentucky a couple of times here. Ken Quesenberry, who is, I think, kind of a generational person who links with Gary Lacefield as well. But Ken was one of my mentors here, as well as John Moore, who's kind of an elite animal scientist, a ruminant nutritionist. So, yeah, between Bill and Jerry and Ken and John, I consider myself to be just unreasonably fortunate in terms of the people who either took an interest in me or felt an obligation to help out this poor soul. But nonetheless, I gained a huge amount from interacting with those guys.
What happened to the international agriculture? Did you find yourself being able to serve in that role, or?
Yeah, so it was a hard decision. I was faced with the choice when I finished. I won't go through all the gory details because it's a fairly long rabbit trail. But my wife and I were looking at a couple of options internationally. And her training is actually in nutrition. She's a registered dietitian. And so we were also keeping in mind where she might land in the future. And so I was applying to graduate schools and for PhD program based in part on where she might end up. And so I applied to Florida as part of that process without really knowing necessarily that was what I wanted to do, but just trying to keep a number of doors, out there as possible openings. And they contacted me and had an opportunity here in Gainesville. And so we had to make a choice at that point. And the choice was either, do we pursue after she had finished and gotten her registration as a dietitian? I had my master's degree, to go international or to come to Florida and do the PhD. And that was a challenging decision for us. And we made the choice to come to Gainesville. As a result of my training here, I've had the opportunity to work with a huge number of international students and travel and work to some extent internationally. So hopefully that was the right choice, and it's definitely been an exciting career option that's given me the opportunity to combine working here in the U.S. with interacting with a large number of really extremely talented people internationally.
Yours was a name that I heard frequently when I was given the opportunity to visit Brazil to attend Integrated Livestock Cropping System conference. And since then, I've become increasingly aware of the connection between Florida and Brazil. So it's interesting, at least in my mind, how, okay, I've got to choose one or the other, and the choice ends up, and you're achieving both. So that serendipity again
Right.
doesn't necessarily mean forever. It just means for now, this is the direction we're going. So I'm not sure that people recognize just how many cattle are in Florida. It's not one of the cattle states that springs to many people's minds. So, what are the challenges that the cattle industry faces in Florida that are kind of unique to Florida?
Right. Well, so when I came to Florida, I knew of Mickey Mouse and I knew of beaches.
No
But that was
rockets?
about the extent of my knowledge. And so I was surprised to learn when I got here that there were, about a million head of beef cattle and about 125,000 dairy cows in the state. I just never envisioned it. And just to put it in perspective, when you talk to Jimmy Henning, he mentioned that Kentucky has the most beef cows of states east of the Mississippi River. And it turns out that Florida is typically in the 2-3 slot. Tennessee and Florida are typically second or third of states east of the Mississippi. And in Florida, it's a cow-calf industry. So, we support the mama cows. They produce a calf hopefully every year. And those calves at weaning then typically, go somewhere else for a intermediate phase that we call backgrounding, and then on to a finishing phase in a feedlot that's typically somewhere in the Midwest, Southern Great Plains. So that's kind of what we're looking at in terms of animals. Some of the distinct challenges in Florida you might anticipate. One of them is heat stress. That is particularly critical in the dairy industry. They say that temperature above 78 degrees Fahrenheit and dairy animal begins to experience heat stress. Well, if you think of the number of days a year when we're above 78, it's a big number. So that's clearly a challenge. One of the challenges we face is the type of plants that we grow well. I come from Pennsylvania, alfalfa, corn silage. That was what it was all about for us and on our dairy farm. What we grow well in Florida are warm season perennial grasses. These are grasses that are of subtropical and tropical origin. And unfortunately, linked with that is a physiological and morphological, kind of how they go about their metabolism and also what they look like, characteristics that don't lend themselves to being extremely high in nutrition. So we have limitations in terms of forage quality. It's also a challenging environment to grow plants. In North Florida, we're right at that transition between where cool season, more temperate plants can be grown and where true tropical plants can be grown. So we're in that kind of a subtropical, give and take. And it means that only the most cold tolerant of the subtropical species can grow there. And we really don't do a very good job with high quality temperate perennials. So we do grow a little bit of alfalfa, and tall fescue comes as close to being a perennial cool season grass that we can grow. So those are some of the key limitations that we deal with. And then I would be remiss if I didn't mention soils. Florida is notorious for sandy soils. So sandy soils do not hold nutrients very well. They are not a very good natural supplier of nutrients. They typically, drainage can be a problem. In some cases, too much, it drains too fast. In other cases, we have this little thing we call a hard pan that's maybe 2 feet below the soil surface. During the summer, when we're getting rain every afternoon, the water fills up between that hard pan and the surface of the soil. And so then we can have poorly drained situations. So there are a lot of challenges to a plant growing in the Florida environment.
And conversion of crop or agricultural land into urbanized areas, and the interface between suburbia and agricultural operations. And I'm imagining all that's...
Absolutely. Thank you for being a good prompter. Yeah, I mean, our producers are clearly dealing with how to manage livestock enterprises on the margins of subdivisions and that, kind of suburban rural interface. And some people have a really good appreciation for what that rural component brings to Florida, and other people have a lesser appreciation of the value of that component of the system. So yes, our producers are very much scrutinized. We have large amounts of surface water. We also have an aquifer. And so nutrient management from a perspective of, everybody has heard of algal blooms. In the Florida context, we also have potential for nitrate issues in groundwater. So, nutrient management programs and care in terms of how we apply and manage nutrients is really a key issue.
Well, that would be a good segue into one particular program that I saw reference to, where you were looking at management of phosphorus nutrition for grass, and came to the understanding that using the standard test, which had been developed over years of calibrating applications, soil test values, and crop yield, wasn't sufficient.
Yeah, so there's a little bit of a story there. I'll give you a little bit of the backstory. I mentioned the soils where there's a hard pan. And it turns out that hard pan is at a depth where forage plant roots can reach it, but it is well below the portion of the soil that we sample. So typically when we take a soil sample, we're sampling what we sometimes refer to as the plow layer, but the top 6 to 8 inches. Typically that hard pan is a couple of feet down. So what is the relevance of that? Well, it turns out that the chemistry of that hardpan, which I won't go into, but it tends to capture phosphorus and hold it. And so when we take a soil sample, we can get a soil sample in the surface soil that says basically we have almost no available phosphorus, as close to zero as you can get, basically. But we have situations where we discovered some time ago that we adding phosphorus and we're not getting a response. So, you scratch the head and say, okay, so what's going on? And so then you figure out, well, obviously the plant is exploring parts of the soil that we are not accounting for in our soil sample and our soil test. And so the way to account for that is basically to ask the plant, what it's accessing. And the way we do that is in order to get a phosphorus recommendation for Bahia grass, which is our primary pasture grass in the southern part of the state where this issue is most prevalent, you also have to submit a plant tissue sample. And some of my colleagues in soil and water sciences have developed then basically an index which tells us, based on the tissue analysis, whether that plant is accessing enough phosphorus to be productive. And so we now use that as the criterion for phosphorus fertilization. And what it means is that in some cases where we would have applied phosphorus and don't need it, we can avoid the potential for negative environmental impacts associated with application of phosphorus that we don't need. And also we're saving the producer the money associated with that application. Or in other cases where we just really don't know whether the plant needs it or not, by looking at the tissue test, we may find out that yes, indeed, it is at a point where it would most definitely be responsive to phosphorus, and we're not in danger of contributing to environmental degradation by applying a, well-targeted amount of P to those soils. So that's the basic story.
And I just find that exciting because as you said, you're asking the plant. The plant is doing all this integration of factors and accessing whatever it can, and then you can sample that and say, based on the research, is that sufficient? Or and as you say, avoid the potential impact as well as the expense. Those are the win-wins that we keep looking for. And some of the systems work that I'm beginning to get familiar with, where they talk about fertilizing the forage in the forage cropping system. And then when they go into the crop, they don't have to put the fertilizer on the crop because it's been cycling through the animal and the forage. Mm-hmm. And now you've got more food produced from the same amount of land with the same or less inputs, and whatever benefit the grass produces in the soil. In one presentation, you talked about, and I wish you had it was on biofuels. And I wish that the graphics had been shown, because you were talking about a Bahia grass, I think. Maybe it was another species growing in a pot that would normally grow a tree. And you had then shown the root mass that grass plant had produced. And I think you said somewhere that the rhizominous peanut, whatever its annual, hay yield would be, that amount of dry matter exists in the soil as root material. So am I having those right?
Right. So your recollection of that information is is spot on. One of the things with the hairgrass that we were interested in was looking at the effects of some different treatments on how it allocated biomass above and below ground, and using the tree pots allowed us to see that. But kind of inadvertently, it gave me this beautiful demonstration for a number of benefits that forage plants bring to the system. That massive root system does an amazing job of holding soil in place. So when we think about erosion that can occur in many agricultural systems, with a perennial grass, that potential for erosion is markedly reduced because of the degree to which the soil is penetrated and effectively held together by that massive biomass underground. Another component of that is that one of the major ways, well, I should preface this by saying that one of the ways that forages contribute tremendously to our overall environment is by reducing the amount of CO2 in the atmosphere. And the way they do that is they take up CO2 as part of photosynthesis, and in this case, they store that carbon in their root system. That root system is perfectly placed then to enhance soil organic matter, soil carbon. And so the fact that these forage plants store so much biomass below ground means that they're storing huge amounts of carbon below ground, which means that they're taking it out of the atmosphere. And so that's a significant contribution. You also mentioned the rhizoma peanut, and it gets its name, rhizoma peanut. Some people call it perennial peanut. Gets the name rhizoma peanut because it has this massive rhizome system. Rhizomes are effectively below ground stems. And for the peanut, they function as just a massive reservoir of carbon for that plant to call on whenever it needs some, and also growing points that it can use to regrow following a defoliation event. So those characteristics of a forage plant in terms of allocating so much carbon below ground really, really have long-term benefits. If you think about the U.S. and where our very richest soils are typically, it's in the Great Plains, the Midwest, where it's basically native grassland for eons of time. And that's where we build up that massive reservoir of organic matter and carbon. And, it may be of interest to some of your listeners that organic matter, not only are we storing carbon and taking out of the air, but that organic matter has a huge impact on the efficiency of agricultural systems. It does a couple of things. One, it gives the soil a huge potential to hold water that is not there if this organic matter is not present. So you can grow a crop with much less rainfall if you have high organic matter than if you have low organic matter. Another thing that organic matter does is that it's really basically our only reservoir of nitrogen. Nitrogen in soils tend to be very mobile and move through soils very quickly. But organic matter holds nitrogen, and it can be released. It's like a slow release fertilizer. So it's slowly releasing nitrogen to the plant. And the other thing that, just off the top of my head, that organic matter does is that it holds important soil nutrients, particularly the cations like potassium, magnesium, and calcium. It has negative charges on it that just serve to adhere or adsorb those nutrient cations. So one of the really striking benefits below ground of forage plants is, as you indicated, that massive accumulation of biomass, which holds soil in place increases water holding potential, increases nutrient holding potential, increases the ability of nutrient supply.
Hmm. Um, so uh, kind of jumping around a little bit here, but the work that you're doing in Florida to address Floridian needs has one question. You're subtropical and maybe a little tropical right at the southern tip, but if we look around the world, how much of the rest of the world is of that tropical, subtropical kind of description when we think about global agriculture and humanity's challenges for the next 30 years trying to increase food production in a sustainable way?
Right. So so clearly, I mean, there's a reason why over time we've had a very significant presence of international students who come to the University of Florida for graduate work. The quality of the program is hopefully one of those. Uh, but also, there is some environmental similarities and components there. It may be of interest that most of the species that we use in Florida come from typically either Africa, and particularly southern part of Africa is an important source at latitudes that are not all that different south of the equator than ours we are north, and also from South America. So there's a lot of sharing of species and compatibility of material in some very important genera where technology is swapped back and forth. Some of that material has been collected and introduced here. Improved genetic material has been developed and distributed elsewhere. So there's significant opportunity for sharing of germplasm and also things that we've learned about management. One thing I would mention that I learned over time, though, is that every environment, and this is maybe one of the really interesting things about working in forage livestock systems, every environment is influenced by a multitude of factors. And some of those factors are biotic, the plants that grow there. Some are abiotic, the soils that are there. But there are a lot of cultural issues. There are a lot of marketing kinds of issues, just overall economic issues. And so when I think about an international context and applying what we do here to other contexts, I've learned over time, in some cases the hard way, to do that with a whole lot of humility. And in fact, I think maybe some of the best ways that we have contributed is by training people who have learned the conceptual framework here and then go and work within an area where they understand all those other pieces and apply the conceptual framework there. I've been somewhat, humbled by going to places like you say, Brazil, where I'm expected to be the expert, but there are people in the room who know 10 times more than I do about what's most appropriate technology and management for that particular environment. So, I try to avoid that ugly American sort of syndrome where we assume we know things that, in fact, we really have no idea about what's going on.
Yeah, it's a little bit more complicated than taking your Forages 300 book and adding the Animal Science 201 book and wrap them up and ship them off and say, there, that's sorted. Lots and lots of issues, although again the principles can be useful as we think about how to move forward? How do we produce the high quality food that humanity needs to flourish, but in a way that at least protects, if not arguably enhances, the environment in which it takes place? You were mentioning before the role that organic matter plays, and in nutrient management, we touched on the phosphorus. But one of the challenges for Florida, and we've here's another question. Sorry. Do the flowers of rhizoma peanut
Uh-huh.
behave the same way as flow runner peanuts do? Is that
So, right. So the perennial peanut does peg and
okay?
it does produce seed underground when it produces seed, but the it it is vegetatively propagated. We plant it using those rhizomes. That was one thing that was just totally blew my mind when I moved to Florida was that you
Sprigging.
actually you plant a whole pasture using either stems, above ground stems, or below ground stems. I just couldn't fathom that coming from Pennsylvania, where everything we planted came from
Mm.
seed, except my mother's African violet. Um, but but yes, it does produce seed underground. It produces very few of them, and so it really depends on vegetative propagation. Let me just throw in one other thing. You mentioned flowers of rhizoma peanut, and one of the things that we're thinking about now. One of my colleagues, Jose Dubay, and he works up in Mariana in North Florida on the Panhandle. In his group, they're very interested in this whole category that we call ecosystem services. And one of the things that he's looking at relative to this integration of multiple species within a pasture context, and particularly flowering legumes, is the whole idea of pollinator habitat. Because if you, I'm sure you are familiar, and probably most of your audience is, but we have some significant issues with the decline of population of pollinators, and there's a whole bunch of backstories there. But um, one of the things that we can do within a forage context, and Dr. DeBea and his students have looked at this, is by integrating cool season forages like some of the clovers and a warm season forage like rhizoma peanut. Uh, there is a very excellent response in terms of pollinator populations that can be associated with integrating some additional non-traditional species, perhaps, into the forage system.
So the peanut is the peanut's not a C4, is it? It's a
It,
C3.
that's correct. It is a C3 plant. So it is one of it. As I talk to my undergraduates, yeah, I I tell them just think all legumes. C3. We have warm climate legumes that are
Yeah.
actually adapted to a little higher temperature regime, but it's not because they have a different metabolism. They're still C3 plants.
So a C4 grass would be more water efficient than even a warm season legume. Is that right?
Right. So one of the characteristics, and I don't know how deep in the weeds we're going here,
We'll
Peter,
find out.
but just for the sake of your some of your viewers who may not be plant physiologists, but there's several different ways that plants, we call it fix carbon. In other words, they convert carbon dioxide from the air into carbohydrates that they can use. And depending on the number of carbons involved, we sometimes call them C3 or C4, carbon fixation pathways. The C4 plants, as you mentioned, those are typically those grasses of subtropical and tropical origin, where the C3 plants are all legumes and grasses of temperate origin. One of the little idiosyncrasies of the C4 grasses, those warm climate grasses, is that they typically can produce about twice as much dry matter per unit of water that they take up relative to the temperate species. And we won't go so far into the weeds that we talk about why that's the case. We'll just have to take it at face value today. So
Fair enough.
that has important implications. One of the things, however, that we always try to tell students is that simply because they can produce more biomass per unit of water does not necessarily mean that they are more drought tolerant. Okay, so given water, they can produce more biomass with that water, but drought tolerance varies kind of pretty widely within groups of plants, C3 plants, C4 plants. But yes, you're absolutely correct that they can produce more biomass per unit of water and actually also per unit of nitrogen.
And they tend to grow more at higher temperatures as well than which is appropriate. But for what are the forage legumes that exist that are used in Florida? You mentioned that alfalfa is limited. I'm familiar with Dr. Cousenberry's work with red clover. Crimson clover would be an annual that gets used to a certain extent. After that, I start wondering, okay, so we got peanut. What else is available for, and what's important about legumes, either in grassland systems or as part of cropping systems?
Right. Okay, so I'll try to catch each of those points. If I forget any, you can be my prompt. So one of the challenges is that we don't have particularly a seed propagated perennial legume that is widely used in Florida. Rhizoma peanut planted vegetatively, which adds some cost and management challenges.
Yeah, how long? I mean, that's a perishable product. It's not like I can load a truck out here in the Willamette Valley with a load of rhizomes and ship it all the way to Florida like I can with annual ryegrass seed. How long? I assume there's a digging process somewhere and
That's right.
then a sprigging somewhere. And is that like 12 hours or 24 hours that has to happen?
Yeah, so the guys who do this, commercially, so they're doing it on scale as custom planters. They'll typically dig the night before, and then they'll drive the next day to wherever they're going to plant and plant. It depends on think about silage, perhaps.
Yes.
If you have too big a pile and too much compression and you're excluding oxygen, and you can get overheating and you can start biological processes that you don't want. So you're right, they're definitely perishable. So
Sorry, yeah.
right. So I do have a colleague who is breeding alfalfa, and we've had breeding programs in alfalfa, so we're continuing to work with it. And I actually have a graduate student who's doing an on-farm project where we're seeding alfalfa into Bermuda grass on a large, dairy farm here in north central Florida. So it is being used, but it's just not. I think in PA, I would think about alfalfa as maybe a 5-year proposition. Here we think about it as one really good year, and then kind of a year. All right, and then we're done. So you've got to get your return on it basically in one good and partial second year of production, which is a challenge. So we have, as you mentioned, cool season legumes, the clovers, crimson, red, arrowleaf, white, ball are all used to some extent. Crimson would be the most widely planted in North Florida. Red and white are also pretty widely used. We do have a group of legumes, warm season legumes. They're mostly annuals. And they're mostly used in South Florida for those poorly drained soil environments. I'll just mention them briefly. There's Agronomy. Uh, there is phasey bean. There's one called Carpendismodium. But they're annuals, and they present challenges in terms of getting them back year after year. So for producers, it's a struggle to convince them that they're worth the effort, because it's a management challenge, and we can tell them how to do it. But it's like, okay, well, would you like to run a marathon? I can tell you how to train for one. Well, nah, maybe not.
Yeah. Yeah.
Maybe not. I'm not quite that interested. So yeah.
Yeah. So the contributions that legumes make in forage livestock systems, as well as then when we start thinking about integrated livestock cropping systems.
Right. So one thing we've done with rhizoma peanut is that, and one of my students and I worked on developing kind of the technology, and then Dr. Dubé has taken it and got some on-farm work done and larger scale work done with grazing experiments, where he is planting the peanut in strips in the hair grass. And we're planting it in strips because, one, we have peanut stands that are 60 years old. It lives a very long time. It is very persistent under grazing, and it can spread in warm season perennial grasses. So if you plant in strips, you can plant 30 or 50% of the area, and then over time it will gradually spread to include the entire pasture. So what's the benefit we get from that? Well, legumes fix atmospheric N, so they are higher in protein. They also contribute protein to the associated grass. So it is typically going to be higher in protein than it would be if it was growing alone without nitrogen. Go ahead.
Now, I when I was, when I was in school, we thought of the nitrogen having to cycle through the animal and be redeposited as urine primarily, dung to a less degree. But I think I saw some information in one of the legume seminars that's been going on here, the last 2 weeks,
Right.
where people built special little tubes where the soil was connected, and you actually saw transfer between legume and grass, which is fascinating. That, as you say, it feeds the grass maybe primarily through the animal, but maybe not exclusively.
Yeah. So there are a number of pathways. The most I tell my students that legumes are, at least early in stand life, if you think about a temperate legume like an alfalfa or something, I think the literature would say that they're somewhat like a child. They're very selfish. They don't like to share their toys. So they don't necessarily share a lot of nitrogen with the associated grass unless it's a grazing system. And then, as you point out, the animals are consuming that high protein forage. They're excreting some of that nitrogen back in the form of dung and urine, and the grass is getting access to it. Also, nitrogen becomes available to the associated grass whenever plants die or after significant defoliation events, because legumes tend to slough off either some root or nodules, which then make nitrogen available to the associated grass. Above ground, there's also some senescent material in some cases, or injured material in a grazing situation that an animal may have stepped on or whatever. And as that material breaks down, it's also releasing nitrogen to be made available to the associated grass. So there are a number of pathways. The most immediate impact is in a grazing situation through dung and urine. So then one of the challenges in a forage livestock system where we are also then integrating crops into that system is, can we then capitalize on that nitrogen in the cropping phase if the crop is a grass, for example. And I mean, if you go back in terms of U.S. agriculture, really prior to World War II, we were mainly using uh, legumes as a source of nitrogen for subsequent grass crops before the common advent of relatively cheap nitrogen fertilizer. So this is old technology, really. And in the early 1900s in Florida, we were growing things like sweet clover as what we call a green manure crop. And it was basically grown not for animal consumption, but to feed the crop that followed. And one of the challenges associated with that, and I don't want to kind of oversell and may present this as a panacea, because one of the challenges we do have is that legume nitrogen tends to be pretty rapidly released and broken down. And so we have to think about timing of when that nitrogen is released relative to when the subsequent crop actually can use it. But clearly, an important mechanism for integrating nitrogen into the system while minimizing the amount of nitrogen fertilizer we apply is by using legumes.
I remember seeing some plots of corn grown in strip-tilled white clover stands. So there's lots of applications, as you said. I think Dr. Tucker at Tifton just gave me the line about sometimes it's not so much about research as search. You go into the literature and find things and then
Absolutely.
see if their time has come. I think about the people, Dr. Mott and others, what could have been done if they had had high tensile, low impedance fencing technology as available as we do, and
Right.
temporary fencing and those sorts of tools that are now available to manage grass and livestock. So if somebody, having listened to our conversation, got really excited about forages, about tropical, subtropical agriculture, what sorts of sources would you recommend for people to learn more?
Yeah. Well, so here at the University of Florida, we have a system called EDIS. It's an acronym, EDIS. And so you can do what I do often is just Google UF EDIS, and you'll come up, it'll be the first thing that pops up in that Google search. And then there are a couple of little subheadings there, and you click agriculture. You click agriculture, and then you go to the website, and there's a search function. And so if you're interested in any forage particularly, you can search it by name, and then publications that are in that system will come up. If you're interested in particular themes, grazing management, forage legumes, those kind of nutrient cycling, you can search themes, and likewise the list of publications that relate to that will come up. So that's a very easy way to get a significant amount of information. And in case you're wondering whether that information is relatively current, we are required, whoever the lead author is on those publications, is required to update those publications at least every 3 years. So they have been read and updated by the lead author at least every third year. So that information is intended to be relatively current. Some of my colleagues, reflecting their greater social media savvy than this gray-haired dinosaur, do an excellent job in terms of communicating their research and some of the things through YouTube videos and Facebook uh, platforms. So particularly Jose Dubé, he's from Brazil, so it's pronounced Jose, but if you speak Spanish instead of Portuguese, it's Jose. But Jose Dubé, uh, he has a lot of stuff that he posts on Facebook, which is great. So, track him down and friend him, and you'll get very regular updates on things that he's doing. And then also one of my colleagues, Marcelo Valao, does a lot of video work with his extension program. And so he posts some really cool videos of ongoing current research that we're involved in. So those are just some of the ways that you can link. And I'm always happy to receive emails and engage in whatever kind of conversation anybody's interested in engaging in.
Well, thank you very much for your time. We were speaking before we started the episode that this is kind of a busy wrap up period in the teaching year, so I appreciate you taking the time. I'll one of my waking nightmares was finding myself in a pickup truck with Gary Lacefield and Don Ball as we were driving through Alabama and Mississippi for several days, and I felt like a graduate student who hadn't studied for his. So I will, with trepidation, open myself up to any questions you might have for me before we wrap up this episode.
Well, the only one you were missing there was Carl Hovland, right?
Oh, yeah. Yeah. Carl is why I'm not a nozzle head.
I think I heard that was that in your podcast with Jimmy Henning, or was I? Yeah, I
probably
heard you mention that. Well, the thing that I'm kind of fascinated with, and Jimmy mentioned this actually in his podcast with you, that once he got into forages, you couldn't really kind of pry him out. I mean, he has been in academic circles as an administrator, as a extensionist, as a researcher for a long, long time. And I skipped the administrative part, but I've been doing this for a long time. So it's interesting to me for someone who regularly kind of reinvents himself and does a greater variety of things. And so I was just curious in knowing a little bit, not a lot, but a little bit about some of the things that you've been involved in. Is apart from maybe your day job, but what do you see kind of as your role as a communicator within the context of speaking, maybe on behalf of someone like me who doesn't do maybe a very good job of communicating my science? But what do you see as your role in kind of maybe bridging that gap between the general public and the scientists, since you kind of have maybe one foot in each side?
Well, first of all, I've watched your in-service training videos, and you do fine. But I think a certain amount of my career track is not necessarily fully considered, if you understand what I'm saying. I mean, there were decisions that got made for a number of reasons, but I'm very grateful for all of it. I find myself where I am and realize I've been given all this training and all this experience. And I think one of the things that's inherent with us in forage livestock systems is we're not specialists. We have to be broad in our outlook. And so My interest in the human health is an extension of that, in part by personal experience, but also because I see the need to answer questions from these researchers and clinicians I've been introduced to, who are, they're dealing with issues, and then people raise issues, and I'm saying, but wait a minute, we know that from the forage agriculture side, so let me give that information to you. And then, the information that these people have is very much applicable to rural America, and especially the southeastern U.S. The chronic disease burdens among people living throughout the southeast, but especially rural populations. So I see it in a way as paying back what I was given by institutions like the University of Georgia and the University of Kentucky, and um, I also see a need for more people to be aware of the history that you laid out with your professor, and then that's cool that it ended up being your grand, yet at the same time current mentor. Because a lot of people don't know that we've gone from this era where, like you said, before World War II, there was a lot of interest in forage agriculture because it was part of the farming system. We were diversified farms. We were needing the legumes as rotational crops, and then we went through this period where we got more specialized and things got separated. We had cheap fertilizer, et cetera, et cetera, et cetera. Um, and so a lot of that information and a lot of those research teams have not been maintained. And so I can think of a lot of institutions that once had very strong forage programs that are virtually non-existent today. And so I I advocate for what I call the ruminant revolution. Just like we needed a green revolution in the 60s, we need a ruminant revolution today in order to achieve these same goals that are ahead of us today. Um, so for me, it's an opportunity, it's a need, and it kind of feels like serendipity again brought me to where I am. Um, and I really am excited about both those topics. Both those sides, I think, have tremendous hope and potential, and we need to make more people aware of them.
Yeah, no, that's interesting, and it does provide, in some ways, an opportunity to extend well beyond our traditional audience who are interested in forages because they're managing forages, but also then make connections to broader human health issues which affect all of us.
Well, if we're going to think about ecosystem services, and I heard somebody recently, and I think it was Dr. Place, made this point that if you want the lowest emission crop, it's sugarcane. If especially if you're talking about yield, right, of caloric yield, could we argue about its downstream impacts and weighing those in the equation? And or conversely, every food producing activity we engage in has an environmental impact. If we look at the ruminant livestock enterprises, then we've got ecosystem services to add into that because they're very different than commodity production. Plus, if I'm right, which is always a useful phrase to keep in mind, if I'm right, then these products actually have been unfairly tainted as health risks and may in fact be key to avoiding the metabolic diseases. And certainly we know from some of your colleagues that these are absolutely essential to avoid the micronutrient deficiencies that are a problem for so many people in other parts of the world. So how do we weigh that appropriately once we remove this, I would say, unfair accusation of being the cause of chronic disease? And if in fact it can be part of reversing type 2 diabetes and that burden, then that ecosystem services equation actually becomes incredibly positive for ruminant animal agriculture.
Yeah. One of the things that's interested me is that a lot of the technological advances that I've observed in terms of addressing particularly environmental issues has been progress that was made at the margins, but then progressively. And, I see really myself and my colleagues fitting into that role that, yes, we recognize that ruminant animals emit methane. We also recognize that automobiles have a negative impact on the environment. We're not going to discard either one of those, but what we are going to do is work as hard as we can and as quickly as we can to mitigate those challenges and to come up with technologies that address some of those critical issues. So I think that's really an important challenge for us to keep making those what seemingly are small gains, but as they continue to accrue, have huge impacts over time.
Well, and also to accurately quantify these things, which too frequently the conversation seems to be well ahead of the data. And then there's a certain amount of catch up. But I was just looking at numbers, and I may be a little off, but I think Brazil has like 2.5 times the number of cattle as the United States, but they produce 75% of the beef that we produce. So when we talk about reducing impact, clearly issues of productivity and efficiency play a huge part in there. And speaking with a gentleman from Southern Africa, and I think we're somewhere around 12 kg CO2 equivalent per kilogram beef, and they're like 70.
Mm-hmm.
So these issues, as you say, may be marginal, but could reflect significant improvement in the livelihoods of those people, as well as animal welfare, as well as the environmental footprint. So I encourage everybody to look at forages as a possible career. And it sometimes is a little disconcerting when I look at audiences of undergraduates and go, oh, 2050 is still your professional career, isn't it?
Right.
And I think I heard you make some comment about, well, maybe I will make predictions because I won't be around by then. But that could lead us into a whole nother conversation. Dr. Sollenberger, thank you so much for the time and for this information. And I look forward to the next time. I look forward to visiting Gainesville sometime.
Let us know when you're coming. We'll be happy to host you and show you around.
Thank you very much.
It's been a pleasure.
Likewise.